The first type of exponential equations that we're going to solve are exponential equations that have exponents on both sides and bases that are the same on both sides. So the property is, if you have b to the x equals b to the y, then x must equal y. If you have the same base on both sides, then the exponents must also be equal. So in number 1, 5 raised to the 3x minus 2 equals 5 raised to the 5x plus 8. Do you notice the 5's are the same on both sides? Because of the rules of an equal sign, if you've got 5's on both sides and both of those 5's have exponents, those exponents must be the same. So the exponent 3x minus 2 and the exponent 5x plus 8 must be equal. 3x minus 2 equals 5x plus 8. So we just took what looked like a really scary looking equation, and is this equation really all that scary? No. How would you solve this? Subtract 3x on both sides. So we have negative 2 equals 2x plus 8. Subtract 8 on both sides. Negative 10 equals 2x. Divide by 2. X equals negative 5. Easy peasy? Okay, number 2, when I was typing this in, I didn't realize that that minus 1 didn't end up in the exponent. So this should say e to the 3x equals e raised to the 2x minus 1. That minus 1 should be in the parentheses, or in the exponent. Notice the e's match on both sides. If the bases match on both sides, then the exponents have to match on both sides. So 3x must equal 2x minus 1. Do we need to actually solve that fully out, or do you know how to solve that equation? You know how to solve that equation. Moving on. So take a look at number 3. Do you see a problem in number 3? The bases are not the same. When the bases are not the same, we need to try to make the bases be the same. So think about 8 in terms of 2. We want 8 to be 2 raised to the something. So think about 2 squared is 4. What's 2 to the third? 8. So I'm going to write in here 8 equals 2 to the third. I'm going to replace 8 with 2 to the third. So instead of this 8, we're going to write 2 to the third, and then put whatever was in the parentheses before, or was ever in the exponent before, in parentheses, equals 2 to the 5x plus 2. Okay. So 8 was replaced with 2 to the third. Whatever exponent was originally on the 8, that exponent goes in parentheses right after the 3 that we stuck in there. We changed 8 to 2 to the third. Now the exponents are going to be the same because the bases are the same. We have 2 to the something equals 2 to the something, so those two somethings must be equal. So 3 times x is going to equal 5x plus 2. Why do you suppose I put parentheses here? What do you think? What if this had been x plus 1? If the original exponent had been x plus 1, and then you're sticking that 3 into the exponent, you would have to multiply that 3 into everything that was originally in the exponent. So that's why I suggest putting parentheses around that original exponent, so that if there's something like x plus 1, or if it was 5x plus 2, or whatever, that you would remember to distribute. So this is 3x equals 5x plus 2. I'm going to trust that you know how to solve that equation. Okay? Number 4, our bases do not match. We have 27 and 3. Always take your bigger base, 27, and try to write it in terms of your smaller base, 3. So can we do 3 raised to something to give us 27? 3 to the third. On a test, it's probably going to be numbers like 3 and 9, and all you have to do is replace 9 with 3 squared. It's going to be something that you can pretty much look at and say, oh, hey, 9 is 3 squared. But for these, we're doing something a little bit more complex. So this 27 is replaced with 3 to the third. The original exponent 2x is going to go in parentheses, still in the exponent. If that 2x had been a 2x plus 1, you would need to distribute that 3 into the parentheses. So 3 to the something equals 3 to the something. That means the two somethings are equal. So 6x must equal 5. You could finish solving that equation. Now let's turn the page and look at the second type of equation we're going to see today. So far we've done type 1, which is exponents on both sides, but you can write them on both sides with the same base. On the next page, we're going to have type 2 and type 3. Almost sounds like biology class. We're not talking about diabetes, though. If there's only one exponent, so number 5 is a type 2, number 7 is a type 2. There's only one exponent. If there's only one exponent, you isolate the exponent term first, and then change to log form. So in number 5, 2 to the x is currently isolated. There's nothing being added after it. There's nothing being multiplied in front of it. It is isolated. So we're going to change forms. Do you remember the log ride? Woo! Woo! You guys don't seem very enthused by the log ride. There we go. Okay, take the log ride. Woo! Log base 2 of 7 equals x. If you have a fancy schmancy calculator, you can punch in alpha window and do log base and then fill in the 2 and the 7 and figure out what it equals. If you don't have a fancy schmancy calculator, you can use the change of base formula and do log button 7 divided by log button 2. And log 7 divided by log 2, what is that? Approximately 2.81. Okay, let's skip down to number 7 so we can do all of the type 2 problems at the same time. Number 7 is the exponent term isolated. How can we get rid of the 4 that's in front of the exponent term? Divide both sides by 4. So we have e to the 3x equals 3. We need to do the log ride. So log base e, woo! Log base e of 3 equals 3x. Okay. Are any bells ringing in anybody's head? What is log base e? Log base e is ln. This is ln of 3 equals 3x. Anytime you see log base e, you can replace it with ln. And this is even easier to punch into your calculator because you don't need a fancy schmancy calculator at all. You simply grab your whatever calculator, as long as it has an ln button. ln 3, I believe, is like 1.099. And then to finish solving this equation, to get x by itself, what would we need to do? Divide both sides by 3. If we divide both sides by 3, 1.099 divided by 3 is 0.366. Type 3 have 2 exponents. and the bases cannot be written as the same thing. If you think about 4 and 9, can you rewrite 9 as 4 raised to the something? No, not easily at least. So if you can't make the bases match and there's exponents on both sides, you are going to take the log of both sides. So number 6 is a type 3, number 8 is a type 3. These are going to require a little bit of work, and there's not a ton of space, so just keep that in mind and try not to write huge on these problems. First thing we're going to do is log of 4 to the x equals log of 9 raised to the x minus 2. Does anyone remember from last week what happens to exponents inside logarithms? They move to the front and become coefficients. So this is x times the log of 4 equals x minus 2 times the log of 9. The next step requires a little bit of strategy. I do not want to multiply some crazy decimal into a set of parentheses. I don't want to have to do some crazy decimal and distribute it into x minus 2. So I'm going to divide both sides by the log of 9. That will cancel the log of 9 from the right side of our equation. Okay, so in my calculator, log of 4 divided by log of 9 is 0.6309. So this thing, log of 4 divided by log of 9, became the decimal 0.6309, and that's still times x on that side. On the right side, we simply have x minus 2. To finish solving this equation, this is a 1x. We want to get all the x's to the same side, so we are going to subtract 1x from both sides. Yes, this is a crazy decimal, but it's still something x minus 1x. So we can do 0.6309 minus 1. That gives us negative 0.3691x equals negative 2. Your last step then is to divide by that crazy decimal.
Well, you said 0.
The answer to this would then be x equals 5.42. I had the question, why is there still an x on the left side after you subtract 1x? Think of it, if this decimal, if that was like 5x minus 1x, we would have 4x. You're just subtracting the coefficients. This is still something x minus 1x, so do that something minus 1 to get your decimal times x. You're just subtracting the coefficients. This particular type is a little bit more complex. Let's recap what we did. If you've got an exponent on both sides and you can't get the same base, take the log of both sides. By taking the log of both sides, you can move those exponents in front. Once you move the exponents in front, then you have to think about getting the log away from the more complex one. So x minus 2 is more complex. You want to get that log out of there. So divide both sides by the log of 9. Do this division to get something times x, and then finish solving the equation to get x by itself. I would like you to try number 8 on your own, and then play, so pause the video if you're watching the video, try number 8 on your own, and then play the video. I've got about 25 seconds to show you the answer before I run out of recording space. We started by taking the log of both sides. When you take the log of both sides, these exponents move down in front. So in green, we've got the exponents in front now with the logs. Look for which one is more complex, divide both sides by that, get your decimal, and then slowly finish.